Hello my dear children. Today we will begin with the chapter Operation on Rational Numbers. In this chapter we will study about what are rational numbers and how we can perform different operations like multiplication, division, subtraction, addition on them. Okay? So moving forward, what are rational numbers? Now pay attention on this number line very carefully. Numbers like 1, 2, 3, 4 and so on till the infinity are known as natural numbers. I repeat, numbers from 1, 2, 3 and so on are known as natural numbers. If we place 0 in the natural number set, then it becomes whole numbers. Then I can say numbers like 0, 1, 2, 3, 4 and so on are whole numbers. Now suppose I want to include this entire number line. If I include the entire number line, they are known as integers. Moving forward, we can say that numbers like all the natural numbers, all the whole numbers and all the negative numbers are all combined together integers. Integers can be represented in fraction form. Let me show you some examples of it. Now, the number 2 can be represented as 2 upon 1. It can also be represented as minus 2 upon minus 1. The value is still 2. If I cancel this minus sign and the denominator minus sign, both gets cancelled and you get the answer 2. Similarly, we can represent the number 5 as 35 upon 7. 7 ones are 7, 7 fives are 35. So the answer will be 5. We can also represent it as minus 35 upon 7. If we solve this, we get the answer 5 again. Even 30 upon 6, we get answer 5. Therefore, these are integers and they can be represented in fraction forms. As you can see, we can put any other numbers also. Therefore, we can say that natural numbers, whole numbers, these natural numbers, whole numbers, integers, and the integers represented in the fraction form, all of these are known as rational numbers. Let's know the correct definition of rational numbers. Integers can be written in the form of m upon n, which is a fraction. If m, that is the numerator, is any integer and n is any non-zero integer. Non-zero means the denominator should never be 0. If the denominator is 0, then the number is not a rational number. Okay? Then I repeat the statement again. Integers can be written in the form of m upon n if m is any integer and n is any non-zero integer, then m upon n is a rational number. Am I clear? Now, again I repeat, if the denominator is 0, then the number is not a rational number. Now let's check some examples of rational numbers. Here are some examples of rational numbers. Now 7 upon 1 is in the form of m upon n. M is an integer? Yes. N is a non-zero integer? Again yes. So it's a rational number. Next, minus 11 upon 2. Let's check. Both are integers? Yes. Is there any 0 here? No. So this is also a rational number. Let's check the next one. Again, Our numerator and denominator both are non-zero integers. Therefore, again, these are rational number. Now here, if you can see, the numerator is 0. Yes, 0 comes in whole number, so it's a part of integer. Denominator is again 9. It is integer, so this is a rational number. Let's look at the next example. Now 9 upon 0. Here numerator is an integer, but denominator is 0. So as you remember that our denominator should be a non-zero integer. Here the denominator is 0. That's why this is not a rational number. Again, the number 2 is integer. So it is a rational number. Minus 5 is also an example of rational number. Let's begin operations on rational number and practice set 22. Our first question reads, carry out the following additions of rational numbers. That means we have to add the rational numbers. The first question is 5 upon 36 plus 6 upon 42. Now in this sum, what do we have to do is we have to find LCM of the denominators and equalize the denominator. So to equalize the denominator, we have to find the LCM. I have found the LCM of the denominator in our rough column with a pencil. As you can see here in the rough column, I have found the LCM of the denominator. The LCM is 252. So I already got, this is supposed to be my new denominator. Now I'll go back to my sum. I have copied down the sum as it is. Copy down the sum as it is. Now the LCM was 252 here. 252. To make 36 252, we will have to multiply it by 7. To make 42 equal to 252, we have to multiply it by 6. Now whatever we multiply in the denominator, we have to multiply the same thing in the numerator also. So I'll multiply here by 7 and I will multiply here by 6. Now after we multiply, what is the answer? We can write it together like this. I wrote 252 because both the denominators are giving me the same answer. So I wrote 252. 5 into 7 is 35. 6 into 6 is 36. So 35 plus 36, my answer is 71 upon 252. This is my final answer. Children, I have not showed you how to find the LCM because we have already done the chapter HCF and LCM in the unit test, and you are supposed to know how to find LCM of any two numbers. In case you have forgotten, you can go back to the LCM videos and watch them. Moving forward to sum number 2. Here the sum is in mixed fraction form. So let's first convert it into proper fractions. So we'll say 3. Here this is multiplication, here it is addition. 3 ones are 3 plus 2, 5. So this becomes 5 upon 3. Here 5 into 2 plus 4 is 14. 14 upon 5. So this is the fraction that we have to add. Again, we will have to find LCM of these two numbers. So as you can see here, LCM of 3 and 5 is 15. So we have to make our denominator 15. Now To make this denominator 15, what should I multiply here? 3 watts are 15. 3 5s are 15. Whatever I multiply to the denominator, I will multiply to the numerator also with a pencil. 5 watts are 15. 5 3s are. So this will also get multiplied by 3. Now the denominator is supposed to be 15. 5 5s are 25. 14 3s are 42. Now we can add the numerator very happily. So our answer is 67 upon 15. Boys, please remember, do not add the denominators. We only have to add the numerator. We have to equalize the denominator. The denominator has to be equalized by finding the LCM. Moving forward to sum number 3, 11 upon 17 plus 13 upon 19. Now here 17 and 19 both are prime numbers. So when we find LCM, it will be multiplication of both the numbers. As you can see here, the LCM will be 323. So our denominator should be 323. So as you can see here, it is 17 into 19 straight away. The LCM is 17 into 19. So to make the denominator 323, we will have to multiply 19 here. If the denominator is multiplied by 19, the numerator will also be multiplied by 19. Here, this will be multiplied by 17. So after the multiplication, 11 into 19 will be 209 plus 13 into 17 will be 221. Our denominator will be 323 like we saw here in the LCM. So after addition, it becomes 430 upon 323. I hope it is simple enough. Let's continue with the next sum. Our next sum is a mixed fraction. We'll make it a proper fraction. So 11 into 2 is 22 plus 3 is 25. So this becomes 25 upon 11. 77 into 1 is 77 plus 3 is 80. So this becomes 80 upon 77. Now in this, if you see, boys, you don't even need to find the LCM, but for a safer side, I have found the LCM here, which is 77. In this, you can see that 77 goes in 11 times table straight away. So if I multiply this by 7, I will get the answer 77. Here I will not have to multiply anything. So I can say, even if you find the LCM, it's 77. So we have to make the denominator 77. I will multiply by this by 7. This will not get multiplied by anything, but you can just write your multiply by 1. Multiply by 1. Okay. So after we multiply, we get the denominator 77. 25 into 7 is 175 plus 18 into 1 is 80. So our answer is 255 upon 77. Now we already learned how to add the fractions. Now we are going to subtract the fractions. Addition and subtraction of the fractions, the steps are similar. Only instead of adding there here you have to just subtract. Rest all the steps are going to be the same. So let's begin with sum number 1. The first sum says 7 upon 11 minus 3 upon 7. Here, let's find the LCM. The LCM is 77. Simple enough. So, what are we going to do is, we have to make the denominator 77. To make it 77, we have to multiply this by 7. 11 sevens are 77. If we multiply the denominator, we multiply the numerator also. To make this 77, I have to multiply this by 11. If the denominator is multiplied by 11, the numerator will also be multiplied by 11. So our answer becomes 7 sevens are 49 minus 33 upon 77. After we subtract, our answer is 16 upon 77. It is very simple. The next sum is 13 upon 36 minus 2 upon 40. Here we will have to find the LCM. So let's find the LCM. After finding the LCM, I got the answer 360. So my denominator is supposed to be 360. If you look at this number, it's very easy to make this 360. I'll just multiply this by 10. If I multiply denominator by 10, I multiply numerator also by 10. Now here, if you can see, here it is 40. You know, 4 9s are 36. Therefore, 40 9s are 360. So, this will get multiplied by 9. So, this will also get multiplied by 9. Our answer will be 130 minus 18 upon 360. Therefore, our final answer is going to be 112 upon 360. Now, I expect you to solve these two sums, the other two sums on your own. I'll just show you the steps in very short. Okay. So, this is a mixed fraction. So, you'll write your 3 ones are 3 plus 2 is 5. 5 upon 3 minus 6 3s are 18 plus 5 is 23 upon 6. If we have to subtract them, remember 6 goes in 3 times table. Straight away if we multiply here by 2, then it will become 6. Here we don't have to do anything because then 3 2s are 6 and 6, if you want, you can write 6 ones are. So 10 minus 23 upon 6. This is a very simple sum, boys. You all should be able to do it on your own. Okay. Now here, always remember, you have to subtract and sign off the bigger number. Here the bigger number has minus sign. So it becomes minus 13 upon 6. The next sum, this sum also I want you to do it first on your own and then watch the video. Okay. 2 into 4 is 8 plus 1 is 9. So this becomes 9 upon 2. 3 into 3 is 9 plus 1 is 10. So 10 upon 3. Here these two numbers, if we find LCM of these two numbers, so the LCM will be 6. So I'll straight away write here multiply by 3, multiply by 3. Multiply by 2, multiply by 2. So, again, the denominator is 6 like I told you. 27 minus 20. So, our answer is going to be 7 upon 6. We will do the next part of this practice set in our next video.